Okay.
Okay, so we're talking about statistics, okay, and there are two types of statistics, okay, that we'll cover as part of the two types of statistics, and we'll cover both of them, okay, as part of our discussion. So you have types of statistics. Okay, the foundation or the first type of statistics we call it as descriptive statistics, and this is what we're going to do now. And then we have inferential statistics. This we'll do it later, okay? So after descriptive, we'll get into Python programming. Again, we'll talk about pandas, NumPy, those important data structure which are required for data analysis and machine learning. We'll do that. And then we'll go to inferential, and then we'll go to machine learning. That's how the plan is for next maybe couple of months or maybe 3 months at max. Okay. So what is difference between them? What is descriptive, what is inferential? Descriptive, as name suggests, it is used to describe. It is used to describe your data set. Okay. How is the data, right? Is it good, bad, that kind of thing. So we don't literally say good or bad. Okay. There are different metrics that we talk about from descriptive statistics, which will help us to understand how the data set is behaving. Okay. So as the name suggests, it is used to describe your data, descriptive. That's why it's called descriptive. Okay. It is used to describe the data. Mostly when talk about data analytics, this is what we talk about. Okay. Descriptive statistics, okay, is the foundation for data analytics. Okay. Yeah, we use data analytics or business analytics to describe the business, describe the data, right? So we use descriptive statistics. Okay, let's understand a little bit about inferential, and then of course for next couple of weeks we will talk about descriptive statistics itself. Okay, so inferential statistics, as again name suggests, here we are going to infer. So you have some data, you have limited data, or you have, let's say, past data. That's what we do in machine learning. You have past data, and based on past data, you infer what would happen in future. You're trying to predict. Infer means you're trying to predict, right? So if you look at this election time, correct? So if you look at these TV channels, they interview 25,000 people, 50,000 people, 1 lakh people, 2 lakhs people, and based on those sample size, they are able to predict what will happen at a national level, isn't it? So they are predicting national level, okay, thing where, 60, 70 crore people are going to vote, right? So based on sample of couple of lakhs, they can predict what 50, 60 crore people are going to do. Okay, so that's called inferential statistics. Okay, so in descriptive statistics, entire data set is part of your analysis. If I want to understand how the data is behaving, I need access to all the data. Okay, I need access to all the data. So there's no concept of population or sample in statistics, because everything is taken into account, or everything is taken into calculation. But when you go to inferential statistics, it's about having a sample size. Okay, because you can't interview, can't reach entire population. Okay, it is expensive, not feasible, not possible. Okay, it's not possible to go and talk to everybody, right? It's not possible to in terms of cost, right? Even if you say, okay, let me hire 10 lakh people to invest to get the survey, right? And who's going to pay for that 10 lakh people, right? So financially it may not be possible. Otherwise also it may not be possible to go and talk to all those people, right? So in that case, what we do, okay, in that case, what we do is we depend upon the information shared or information given to us by the sample, right? So inferential statistics, okay, so descriptive statistics is about describing entire data set, and inferential statistics is about inferring about population based on the sample data, right? Sample data is possible to get. So we try to infer what will happen, inferring about population based on sample data, right? Describing the entire data set. Okay. So inferential statistics is the foundation for your probability. Okay. and probability is the foundation for your machine learning. Okay. So that's how, inferential statistics is related to machine learning, and descriptive statistics where you are trying to understand the entire data set. Now, let's say if I have access to entire sales data of my company for last year, what insights can I infer from that? Okay, data always tells a story. Okay, we need to figure out what story data is telling, and that's part of your descriptive statistics. Okay, so for now and for next few hours, okay, we'll focus on descriptive statistics. Okay, so now let's move on to descriptive statistics. I'm going to create a new slide here. Descriptive statistics. Now, descriptive statistics are also made of two types. Okay, so there are two important concepts in descriptive statistics. One concept is called central tendency, and second one is called variability. Okay, so the metric that we use is called measure of, and metric that we use for central tendency is called measure of. Okay. Now, when you have a large data set, right? Of course, you'll come across large data set, right? Now, when you come across large data set, okay. Okay. Now, how do you understand? Okay. How does how do I rate? For example, okay, let's start with an example. If I ask you, how many hours are you studying for data science every day? Okay, how many hours are you studying for data science? Okay, what would be your answer? So see, not every day we spend same number of hours, right? You'll say, yesterday I was busy, I could not spend any hour. Day before I did 2 hours. Before that I did 10 hours. I studied because I was free at home, had nothing else to do, 10 hours. Then before that, you'll keep on telling me that story. Does that make sense? Is this how you describe the data? No. We need to have one metric that can describe your entire story. Instead of telling me your day-wise plan, okay, this is what I did on day 1, day 2, day 3. Okay, you can say on average, I study 2 hours per day. The moment you tell me on average 2 hours, understand that someday you will not be able to study, and someday you'll be able to study 4 hours, 5 hours also. That's what average means, right? So when you talk about central tendency, we're talking about metric which can describe your entire data set, right? So you have metric here like mean, which is your average. Okay, the example that I gave was for average. Mean, median, mode. Okay, so these are your metric. These are different metrics. These are called measure of central tendency. Okay, these are measure of central tendency. These metric help us to define the central value. Define the central value. Now, what does these mean? Okay, let's first understand the meaning of it. Then we will understand the significance of it. Okay, and once we do central tendency, then we will go to variability. Okay, so I'm opening an Excel file. Give me a second. Okay, let's say you have data. Okay, like 50, 55, 55, 60, 60, 60, 70, 70. Okay, let's take smaller data set itself. Okay, 70 will make it 65. 65, 65, and 70. Let's take this data set. Okay, so let's take any example. Let's say I ask you, okay, how good is your English? Okay, so if I ask you how good is your English, you'll tell me, last time in the exam I got 70, before that I got 65, before that I got 65, before that I got 60, before that I got 60. Okay, I say, okay, hold on. Let me take the average of this data and I can probably guess how good is your, not English, I mean, it could be any subject, right? How good your maths, how good is your science. So if assuming that the marks that you obtain in the exam, if that's the criteria for your measuring your knowledge, right? So let's say if I ask you how good is your maths, and measuring the marks that you have got in the exam is the criteria for knowing your maths expertise, the maths knowledge. So I will ask for marks, right? Now you can see that marks will not be exactly same in every exam you write, right? It's not that, even if it is your favorite paper, sometimes you might get less marks, sometimes you might get more marks, isn't it? So let's say this is what I took last 3, 4, 5, 6, 7, 8, 9, right? So I've taken last 9 exams that you have done in maths, okay, and I have put it in the increasing order. Why did I put increasing order? So I'll tell you why. But first metric that we discussed was mean, correct? Mean is your average, right? So how do you calculate mean? Mean is sum of entire data, correct? Divided by total number of data. Mean of entire data divided by total number of data, right? Or you can say average, right? Your mean is average, right? So if you take the mean of this data set, it's 60. Okay. So that means you have scored on average of 60 marks in mathematics or whatever paper. So this will help me to understand, okay, you are so good in the paper. Now we spoke about median. Now median, okay, has a different way of calculation. To calculate median, first you have to put the data in the increasing order. That's why I've already put data in the increasing order. Okay. And median, okay, is about a number that divides the data set into 2 halves. So first you look at, first you have to arrange the data in increasing order, and then you say, okay, this data divides the data into 2 halves. So for example, okay, you have 9 here, right? So if I take 4th value, right? 1, 2, 3, 4, 1, 2, 3, 4, right? 5th value rather, right? Now 60 is dividing your data into 2 halves. This is your bottom half. So on this side, all the values will be lower than median, and this side, all the values will be higher than median. So since we have 9 values here, okay, our median is going to be mid value, which is 5th value. So 5th value is going to divide into 2 halves, right? This is 1 half, this is another half. So what is median value? 60. So to calculate median, first you have to arrange the values and then look at the middle value. So here we have 9 values. So we could easily figure out that, that average value is, median value is 5th one, because 5th has 4 elements on the left and 4 elements on the right. But let's say if I add one more value here, okay, another 50 I add. Now what happens? Okay, now you have 5 values on this side and only 4 on this side. So definitely 60 is not dividing them into 2 halves. In that case, when you have even number of values, if the count is even number, then you will have 2 median values. Then you will have 2 median values. So 60 and 60, okay, these are dividing into 2 halves. So now you take the average of these 2 values. So when you have even number of elements in the series, in the data, then there will be 2 elements which are your middle values. So the median is going to be only 1 value. Median is not going to be 2 values. So median is going to be average of those 2 middle values. Okay. So for now, let's say that 50 is not there. So this is your data set. Your mean is, okay, 60, average is 60, median is also 60. What about mode? What about mode? What is mode? Mode is maximum occurring value. Okay, maximum occurring value is called mode. So which number is appearing maximum number of times? How many times 50 occurs? one time. 50 occurring only one time. 55, two times. 60, three times. 65, two times. 70, two times. So 60 is occurring maximum number of times. So your mode is 60. So in this case, okay, our mean, median, mode, all three are same.
60.
Okay, all three are same. That's 60, correct. Okay, so when you talk about normal distribution, normal data, when talk about, okay, normal, again, we'll talk about normal in maybe tomorrow, okay, in detail. But understand that, okay, when you look at the data set and if your mean, median, mode, okay, in this case, it's exactly 60, but it may not be exact 60, it could be in same range. It's a 61, 60, 62, 63, 62, 65. Okay, in same range, okay, we say that, the, data is normal. Formula has a maximum occurring, right? So you have to do the count for each of the elements.
No, as of now, we have done manually, right? Because it's a list rate.
No. See, formula is there. You have to find the count. Find the count, and then you see the highest value. So you have the top, okay? And for median, you look at the number of elements. So in median, the values doesn't play any role. The position plays a role. How many elements are there? 9. So 9 by 2. 9 by 2 is 4.5, right? So you will say here, when it is 4.5, you take it to 5. So you say fifth element is the median. So fifth element, whatever will be the fifth element, will be the median, right? Irrespective of the value. So when you have a normal distribution, okay, so mean, median, mode is going to be same. Now let's say you add an outlier, okay, something which is out of this league. Okay, what I'll do is I'll pull it up, and here I'll add a value, let's say 600. Now obviously when you look at it, 600 is kind of odd, right? It's an outlier. Now this data doesn't look normal. So it's like 50, 60, 50, 60, you have 600. It's like now you are getting 50, 60 every day, and one day you got 600. Okay, the 600 is definitely outlier. So if you have an outlier and data which is out of league, then what happens to mean, median, mode? Can you tell me? If I have to calculate again, new mean, median, mode, tell me what will be the value? Okay, so mean, okay, I'll calculate it for you. Average here. What happens to median and mode? Tell me. See, now we have 10 elements here, right? So this 60 and this 60 together will be the median, right? Average of 60 and 60. So average of 60 and 60 is 60 only. And mode, maximum occurring. Outlier will have one or two values. Outlier will not be in groups, right? You will not get 600 every time, okay? You got one time 600 because, mostly you get 50s and 60s. One day you got 600, but mostly you'll be 50s and 60s, right? Let's say this is your pocket money, right? So pocket money is 50, 50, 50, 50. One day you got 600, probably because there was some event or something, you're carrying extra money to pay for that event maybe. That's not your pocket money, right? Suddenly it will not become 600 from 60. So your mode will remain unchanged. Now you see here. When you have an outlier, mode had no impact. Absolutely no impact. So when you have an outlier in your data set, mode is not going to change at all. Mode is unaffected by outliers. What about median? Median came from fifth element to sixth element. Not to sixth element, but between 5.5 element, right? So it was what? 1, 2, 3, 4, fifth element, right? Now it is between 5 and 6. So 5.5. It moved slightly downward. So when you have an outliers, mode will not get impacted. That's what we see. Median will get slightly impacted. Median did change, but not by much. Okay, slightly it moved. Now, here also it's 60, but maybe if it was 65, probably it would have become 62, right? If it was 61 here, it would have become 60.5. So it did change very little, very almost negligible, it did change. But what happened to median, mean? What happened to mean? Mean became 114. Now, see, see the message. When I tell you I get around 114 marks. So when I say on average I get 114, what numbers come to your mind? You say, okay, this fellow might be getting between 100 and 130, 140. Right? When I say mean is 114, you will think of numbers between 90 to 150 kind of range. You will not think of 600, and same time you will not think of 50, 55. So what happened? Your mean actually ran very far away. So when you have an outliers, mean changes by a lot. So if you want to know if your data set is normal or not, first test is perform mean and median and see the difference between them. If the difference is very less, like difference of 2, 5, 10, again, depends upon the data, right? If you're talking about lakhs, then difference could be about 10,000. If you're talking about, crores, difference could be about few lakhs. Then you say they are in similar range. But now what happened? Mean became like twice of median. Okay. So what we say here is that this data is not normal. It has some outliers. We call them as skewed data set. Normal data set and opposite of normal is skewed. Now, skew can be positive or negative. Okay, if you have outlier from the positive side, on the higher side, we say positively skewed data set. If your data set is on the lower side, we say negatively skewed data. Okay, so if you had minus 600, for example, minus 400 if you had, then it would have been negatively skewed data. It would have been negatively skewed data. Okay, so you have mean, median, mode, and generally your mean, median, mode does not change. Okay, now coming back to the example again, which metric will you use to describe how many hours you study every day? Tell me. Mean, if you do not have any outliers. One day, let's say you read for 220 hours. You had no work, you were not feeling sleepy, you read 220 hours. And every other day you're reading half an hour, 1 hour, half an hour, 1 hour. Because one day you read 20 hours, your average would become like 5 hours. Right? But again, none of the, second highest is like 1 hour, right? So in that case, okay, mean may not be a good metric to talk about when you have a data, outliers. Then you will say median, okay? Median is about 1 hour, 2 hours, okay? Because, you have 20 hours, I agree, but that is only for one day, right? It's not that you are doing it regularly. One day you read 20 hours should not impact your entire statistics, okay? We do have errors, one day error, right? One day you might have, downtime, okay? Your servers are down. But because, once in a year you have such problem, you should not skew your entire yearly metric. Yes, if you have every other day, every other week, every other month, then it's no longer outlier. But if you're doing once in a year, if you have an outage, then it's an outlier, right? Sometimes we wonder, right? Oh, like let's say power doesn't go, right? And one day power went for an hour. You'll be surprised. Oh, wow, today power went. I don't know why power went for an hour, right? Now, if other way around, every day power goes, then you will not bother, right? You say, okay, it's common every day, right? So that's what outlier is. When it when it catches your attention, oh, there's a high value. That's an outlier. But if you consistently hit outliers, right? If Sachin scores, let's say IPL match, right? If Virat Kohli scores century, Rohit Sharma scores century, okay, it's okay, right? You won't be surprised. But let's say if baller starts scoring centuries, then you say, wow, who's that baller who scored century? Because that you don't expect it. That's outlier. Okay. So outliers will skew your data set. And that's why when you have outliers, we don't generally consider mean. We look at median. Okay, any questions so far? Okay, let's take 1 minute break. Okay, just try to recollect what we have done, and then
Yes, okay.
then we will move ahead. Just try to recollect. Just the formula, okay? Just the formula. Try to recollect.
Okay.
Okay, I'll talk more about these things in some time.
Okay.
Shall we move ahead? Any questions?
No, sir. We can move.
Perfect. I just want to move to another slide. We'll talk about it. Okay. So this is the data set you have in a table. You have batch number 1 to 10. You have sample size. Okay. So let's say you are no, so you are responsible for quality check of a company, factory. Okay. So every day they develop some product and you're part of quality check. So your job is to perform the quality check, right? So you won't be able to check for the entire data, right? They'll be doing in thousands, so you can't test everything. So what you do, you take some sample size. So here you see batch number, or you can count it as days. Okay. First day you took 200 sample size and you saw defective pieces of 12. Okay. Second day you took a batch size of 400 and you found 22 defective pieces. Third day 210 and 424, so on. And 10th day you have 400 sample size and you found 10 defective pieces. So the question here is, okay, if I ask you, okay, how much is the defective pieces? What will you tell me?
Maybe we can take the average.
Average of what?
The number of defects.
Number of defects? But see, the sample size are different, right?
Yeah, separately for 400 and separately for 200.
Okay, and then do what?
Again, do
Because I expect, one answer, right? You say,
yes, yes.
on average, this is the defective pieces, right?
We can combine the 200 parts into a 400 sample size and then combine the defects also.
How do you combine? Let's say you have only 4 days data. Tell me, how will you do only 4 days data? You explain me, then I'll extrapolate for the entire data set. So in this case, you see, you have to have a common denominator, isn't it? Right? So
Yeah.
when you have sample size, it makes more sense to say average defective pieces per 100 sample size or per 200 sample size plus or 400 sample, whatever, right? So denominator has to be same, right? So what you can do is, let's say, instead of saying per 200, it doesn't look good. So I will use word per 100. So for each of this data set, I will calculate defective pieces per 100. So for first one, 12 after 200 is like 6 per 100, isn't it? Then for second one, it is 5.5 per 100, right? 5.5 per 100. Then 5, then 6, then 5, then 1, right? And then I will take average. I'll try to convert them into same denominator, right? Either I do 400 or for 200. See, I can do for 400 also, right? So if you want to do for 400, then for first one, it becomes 12 into 2, right? So 12 out of 200 is like 24 out of 400, right? So you have a choice. You can convert into 400 or 200 or 100. Probably 100 makes more sense. So I will convert all of them into per 100, and then I will take average, and then I will say on average we see 5 defective pieces per 100 pieces, per 100 sample, right? So this is what you'll tell me. Let's say if I am a manager of a management and I ask you, what do you notice? Okay, how's the performance? So you'll say, okay, based on my understanding, you have 5 defective pieces per 100 samples, right? So you need to find out, again, here's average is good, but you also have to understand, okay, that the number should not be misleading. It should not tell you. So when I say 5 means what, right? You say per 100. So that is, of course, one way. Now, so we're talking about central tendency, right? So what is central tendency? Statistical measure or values that describes or summarizes a set of data by identifying the central position within the data set, right? How many hours you study? We're looking for a number that will describe the central position, not the ending position, right? When you talk about, average in outlier, that was second highest value, definitely not the center value, right? That's why we don't take average for outliers, right? So central tendency is about finding a number that describes the central position of the data set. Okay, and these are the metric. Forget about geometric metric and harmonic metric. Okay, we are not geometric mean and harmonic mean. I'm not going to do here. That's not okay part of our descriptive. So the formula we have already discussed. Okay, so let's say you are second question, right? You are manager of a factory, okay, and you're taking care of production. These are the different quantities of products that you are manufacturing. Let's say car manufacturing. So these are the different number of cars that you manufacture every day. First day you manufacture 120 cars, second day 100, third day 80. So again, I ask you, okay, how's going? What will you do? What will you tell me? You'll simply take a average of this data. Okay. So you'll say, oh yeah, we make about 98 products per day, 98 cars per day, right? That's the number that is easy to talk about, right? Let's take another case now. So you are getting customer complaints. Okay, you are now in charge of customer support, and these are customer complaints per day, right? 71, 60, 80, 60. What do you notice here? Anything you notice peculiar? So most of your customer complaints are around 50 to 60. And one day you see this 199 customer complaints, right? Now, in this case, if I take average, you will say average is 72.5 complaints per day, right? If you take average. But before you speak out, before you put that in the presentation, you have to verify, right? You see 72, measure central tendency, you're talking about number that describes central position of the data set. But 72.5 is nowhere in the center. Okay, 72.5 is second highest. 199 is the highest, of course. And all the other metric other than 199 are lower than 72. So in this case, it is not proper to say that average value. Because one day, let's say, some outage happened because of which you're getting a lot of complaints, right? So that's an outlier case. You don't have outages, you don't have power cut every day, right? So that's something, bad happened. So in this case, you will calculate what? Median. Okay, so you will say on average, we have 70 complaints per day with an exception on so-and-so date where we had 199. So you will bring it out. You tell them that one day we had 190. Okay, you want to inform that, okay? Because if I use median, that information also goes away. You are normalizing the data. That information goes away. Of course, we need to normalize, but at the same time, you have to call out. So you can say, okay, on median, okay, we have 60 cases per day, and one day we had this. So that's why, when you look at these uh, colleges, when they talk about the placements, they will say average placement is so much, average package. They'll talk about average package. They will never talk about median package. You should ask them, okay, tell me the median package, not average package. Because one person will be experienced, they might get 50 lakhs, everybody else gets 3 lakhs, package will be shown as 9 lakhs. Because one person got a 50 lakh package, it skewed the data. Everybody else is getting 3 lakhs only. One person got 50 lakh, average becomes 9. So average is easy to influence in both the cases. One time you do bad, your average will fall down. One time you do good, your average will go up. So that's why average may not be a good metric to look at in such cases where you have outliers. So in this case, this is an example where you will use median, not mean. So if you see in both the cases, we are only talking about mean and median, not about mode. Mode is generally is the least important of the all metric. So mean and median are important. Mode is least important. Okay. So sometimes if they ask you which is least important metric, it is mode. But at the same time, mode is also important. Okay. So let's say you want to set up your own ice cream factory. Ice cream manufacturing plant you want to set up. Now, when you look at ice cream plant, there are many flavors, right? You can't sell just one flavor. You have multiple flavors. So you have to have different channels for multiple flavors, right? You have to have different factories, different setup. Initially, you don't want to invest so much. Let's say initially, you don't want to invest so much in all the flavors. You say, okay, I am starting new, so let me invest in one flavor. Let me get experience. Let me say, understand the process. And then slowly I will add more flavors to it. So question comes, which flavor will you start? So you'll say, okay, of course, the most popular flavor you'll start with, correct? So you have taken a survey and let's say you figure out that vanilla ice cream is the most popular ice cream. So what will you do? You'll start with vanilla. That is nothing but your mode. Okay, maximum choice is nothing but your mode, isn't it? Right? So this is an application of mode, right? You want to understand which ice cream, should I start? So you're going by the audience poll. Vanilla got the maximum points, maximum vote. That is nothing but mode. So you go with mode with the data, right? That's application of mode. This is another example here. Let's say your friend is running a shoe shop, okay, and this friend of yours is not able to manage inventory better. He keeps complaining to you. Since you are a data scientist, please help me to understand my business. I'm not able to sell. Stocks. My stocks are getting old, and I lose money. Right? Obviously, when you buy a stock and you're not able to sell, you lose money. So you're saying, okay, help me to understand the business problem and improve my process. So you'll say, okay, tell me, okay, how many sales you are doing for each shoe size. And you'll make a table like this. So shoe size 4, you sell 2. Shoe size 5, you sell 5. Shoe size 6, you sell 32, 7, 33, 10, and 25. So when you look at this data, you know that, okay, now in this case, okay, 33, of course, 8 is the mode, right? Size 8 is mode because you are selling maximum number of size 8. But again, 6 and 7 are also in similar range. Okay, just difference of 1 we can ignore. So in this case, you can say there are 3 modes, size 6, 7, 8. So what will you tell your friend? You will tell to your friend that carry more products, inventory of 6, 7, 8. Okay, and maybe let's say up to 10 also, and 10. But carry very few, less inventory of 2, 5.
Sir, sorry to interrupt you, but have you changed the screen to Excel or any other screen?
What are you noticing?
Okay, okay. Before, I was seeing that an old defects table.
Is it? What do you see now?
Now I'm able to see the shoe example.
Okay, from when?
From the defects topic, it was that only. I thought you were just telling it vocally instead of changing it on slides, but then I just wanted to confirm.
No. I had these slides. Okay.
Okay, okay. No problem, sir.
Ah, sure. So yeah, I mean, see, I'm just trying to say that when you have outliers, use median. When you don't have outliers, use mean. And with shoe example, okay, again, you're telling your friend that your 6, 7, 8 is selling more, so carry more of those sizes shoes. Generally, what you do, you carry equal number of shoes, but you don't sell equal number of shoes, right? Highest numbers that you sell are your mode. So carry more product of mode and less products of non-mode numbers. So that's application of mode again, with knowledge of mode, you're able to solve this problem, right? So yeah, so these are applications and importance of your mean median mode. Okay, so these are your metric for central tendency. Okay, in this case, we'll stop here and we'll move back to our original data set. Shall we take 5 minutes break now before we get
Yes.
into next set of central variability?
Yes, sir.
Okay. Yeah, so we'll see in now we'll talk about variability. Okay, central tendency gives you a central value, but it does not talk about the spread, right? So if I say average is 100, now is it between 90 to 110? Is it between 80 to 120? Is it between 50 to 150? That we don't know. So this is where variability comes into picture. So if you have to describe a number, okay, we describe with central tendency, the middle value, and how much variance, how much deviation is there in the data. So deviation or the variance or the variability is what we talk about here. So here also you have some metric. You have metric like range. Okay, you have interquartile range. You have variance, and you have standard deviation. Okay, so these are the metric that we cover as part of variability. Okay, so again, first let's go and see what each of these things mean, and then we'll talk about the importance of these. So I'm going back to same original sheet. Okay, so let me delete this 600. Okay, we'll have only this data. Okay, now when we have this, okay, now you're talking about range. Range. So range is maximum minus minimum. Okay, so what is maximum? 70. What is minimum? 50. So range is 20. So it tells you from maximum to minimum, what is the range? So now if average is 60 and range is 20, you can to an extent guess the range of values, right? Range is 20 and your average is 60. So, so range is like from last to end. So midway will be about 10. That means you have mean plus or minus 10. That's what the number is about. So if it's a 60, so you have values between 50 to 70. Okay, that's how you know, okay, it's in 50 to 70. If range was higher, means the deviation is also higher. Let's say if I had 30 here and 100 here, the range would have become 70. And mean would probably have been same. You never know, right? Mean would have been same. So the range is one metric which kind of gives you an idea. Okay, how much is the deviation? Next one you have is called IQR, interquartile range. But before we do interquartile range or IQR, we need to understand what is quartile. Okay, what is quartile? You must have heard the word percentile, right? What is percentile? Percentile is dividing the data into 100 parts. Okay, so let's say if this is your data range, and if I talk about percentile, so I'm saying I'm dividing the data into 100 parts, and each of the part, okay, so when you hear percentile, quantile, quartile, and median, this is an extension of concept of median. Quartile, percentile is an extension of median. Median means you're dividing the data into halves, right? So you get, this half like this. Okay. Quartile is dividing data into 4 parts. You're dividing into one part. Yes, quarters. Right? One part, two part, 3 part, and then 4 parts. Decile means dividing data into 10 parts. Decile means you are dividing data into 10 parts. Percentile is dividing into 100 parts. So when you hear, okay, percentile is 100 parts, okay, and quantile is all of these are quantile only, okay. Okay, so quantile probably I should not write here. I should write as a header. So these are called quantiles. Okay, percentile, quartile, median, decile. Okay, so percentile means, okay, you are dividing the entire, let's say if 1 lakh student appeared for the exam. So you divide this 1 lakh student into 100 parts. So how many students will be in each part? 100 students. 100 into 100 is 1 lakh, correct? 100 into 100 is 10,000. No. 100 into 100 is 10,000. So 1 lakh means each group will have 1,000 students. Okay. So each group, when you divide this entire 1 lakh student into 100 groups, each group will have 1,000 students. So the bottom 1,000 student is said to be in 1 percentile. Second last, so rank 1,001 to 2,000 are said to be second percentile. Similarly, you have 99 percentile, 100 percentile. 100 percentile means you are the topper. Okay, everybody else is below you. Okay, and 99 percentile means 99% of people are below you. You are in top 1 percentile. 99 percentile means you are in top, okay, percentile. So when you talk about median means you're talking about 50 group, 50 percentile. Okay. So in interquartile range, what we say is divide this data into 4 parts. That means you take the data set, you find median, like the way you find median in earlier, like we discussed here, right? You find median. So in this case, this becomes 1/2, this becomes another half. So you find median, this is one median, this is another median. Once you find the median, then again you find the median in lower half and in the upper half. So you are finding median of the medians that you created. So first you divide into 2 halves, and then you find median of lower half, and you find median of upper half. Find median of lower half and upper half. Okay, so now your data set got divided into 4 parts. lowest value, okay, the minimum value is the lowest value. This is called Q0. Okay, Q1 is this quartile. Okay, this is called Q1. Q0 means minimum value. Q0, percentile 0, decile 0, 0 means minimum value. Percentile 100. Q4, like when you talk about quartile, fourth quarter is the highest value. Talk about percentile, 100 is the highest value. So those are like your highest value. Q4 is the maximum value, highest value. Okay. So you have Q0 lowest, Q1 is the highest value in the first quartile. Then this is called Q2. Q2 is same as median. Q2 is same as median. See, this is Q2 and this is median also, isn't it? So Q2 is same as median, and then you have Q3. Okay, so you have Q0, Q1, Q2, Q3, Q4. You are dividing the data into 4 parts. Range is like Q4 minus Q0. Range is Q4 minus Q0. That's what we did, right? We took the highest value and subtracted it with lowest value. That's your range. Interquartile range is Q3 minus Q1. Q3 minus Q1. So you are taking the highest value in quartile. So basically what you're doing is you are dividing into 4 parts, removing first and last part, and then finding the range. So this is your entire data set. So you're taking entire data set. Now I'm saying, okay, I don't want this part, I don't want this part. So you're finding range of middle 50% of the data. You are finding range of middle 50% of the data, right? If you remove data from here, if you remove data from here, then Q3 becomes highest, Q1 becomes the lowest. So Q3 minus Q1 is your interquartile range. Now, what is the significance of interquartile range? If you have any outliers, they will be removed. If you have any outliers, they will be removed. That's the significance of interquartile range. Now, let's say if I have 600 here, okay, 600 here, then imagine the range would have been what? 600 minus 50, 590. Very high. Median itself is 60, range becomes 590. So median is 60, mean is 60, median is 60, and range is 550. What does that mean? It means your value ranges from minus 500 to plus 500, or minus 300 to plus 300, around 600, right? 500 something. So that gives a wrong impression. So just like outliers can have problem on your average, outliers can have problem on your range also. So what we are saying, okay, let's, instead of taking range, let's take interquartile range. Let's ignore 1 quarter data both the sides. So in assumption, in anticipation that outliers will be on both the ends, right? It can be lower value, it can be higher value. So by doing so, your outliers are removed. You are left with only good values. That's what interquartile range is there. So if we have outliers, definitely IQR is best. Okay. So you have IQR. Then you have variance and standard deviation. Okay. We will do this and we will stop for today. Variance and standard deviation. Then what is variance and what is standard deviation? It's a kind of difference. Yes. And we will see what kind of difference it is. Okay. So let's say this is your, I'll have some space created here. अभी आज बोलूंगा ना आपको दिमाग से निकलेगा नहीं. Okay, listen to this. Okay, you will not forget ever. Okay, so now what is the average? Remove 600. What is the average here? Average is 60, correct? Now, what is the intention of doing variability? How far it is away from average or expected value. We call it as expected value. In data science, again, we'll talk about same concept. There we'll talk about expected value or predict, what you expect from machine and what machine gave you. So that's why sometimes average is also called as expected value. Okay. So, but here pure statistics, we'll talk about average only, no expected value. So average is 60. Okay. But you are getting what? You are getting 50. So what is the difference? What is the gap? So this is your difference. So difference means you talk about 50 minus mean, minus average, assuming the data set is normal, okay? So I'm going to fix this mean value here. B13, B13. Okay? So your difference here is 50, so minus 10. 55, so minus 5, minus 5. Here same as average, correct? So difference is 0. Now, what is the average difference? So we will calculate what is called as average difference. What is the average difference? So average of the difference, right? Average of difference. So these are your difference, right? Average difference. So what is average difference? 0. Why it is 0? See, we took difference, right? Now difference means what? There is one plus difference, one minus difference. They're canceling out. See, minus 10 plus 10, minus 5 minus 5 plus 5 plus 5. They're canceling out. Since they're canceling out, okay, since they're canceling out, your total is 0. So when you look at this number, what does it mean? Oh, no deviation, no difference, 0 difference. That means it is exactly mean value. Is it correct? No, it's not correct. So for imagine, okay, let's say you want to buy a car and you go to this car showroom. Okay, so what these guys do, they are promising you 60 days of delivery. They say on average 2 months waiting period you get on 60th day. But what happens actually? So this is what they promise. Okay, expected value, okay, is your 60. But what is happening is they're calling on 50th day. Your car is ready, please come and pick it up. So sometimes they're calling you on day 50th, sometimes 55, some 55, 60, 60, sometimes 70 also they're calling you. On 60, when you go and say, sorry, sir, car has not come yet, we'll call you. So on 78th day, they're calling you and saying your car is ready, please come and pick it up. Right? So they're promising you 60, but they are breaking their promise most of the time. So on average, how many days are they breaking your promise? On average, it said 0. Is it correct? No, it's not correct. Delivering early is also a problem. Same number of, it's same problem as delivering late. Let's say you're not in town because you have 60 days in mind. On 50th day, they call you, you're not in town. They say, sir, your car has come. You come and take it or we will give to somebody else. That's also a problem, isn't it? You say, I was expecting on 60th day. I'm not in town. I don't have money. Maybe you are trying to, break your mutual funds and, get some money. We have not, because you have planned for 60th day, right? So that's why you have planned. On 50th day, you're not ready to pick your car. You lose the car, right? Then again, you have to wait for another 2 months. Now, so what is happening here is, again, let's say umpire, right? Now, umpire might make a mistake for team 1, favor of team 1, and then again make mistake in favor of team 2. So do you say that mistakes and mistakes will cancel out? No. Okay. See, when umpire makes a mistake, umpire doesn't want to make another mistake in favor of other team, saying, okay, I'll make one mistake in this team, one mistake in other team. It becomes 0 mistake. No. Mistake is a mistake. Deviation is a deviation. So this is not the right way to do it. This is not the right way. Average difference is not the right way to do it. We want to have a method where Both are, all of them are positive. See, this is also a difference. This is also a difference. This should add up to be 20, not 0. You understood what I'm trying to say? It is a deviation. This is a deviation. So deviation has to be positive, not negative. So this is not the right way. You use this, okay, your minus and plus are cancelling, and that should not happen. Mistake is a mistake. Deviation is a deviation. So this is not the right way. So how can you make negative numbers positive? How can you make negative numbers positive? There are two ways to do it. Okay, one way is to find absolute difference. Absolute value. Absolute value of negative numbers are also positive. One way is you make absolute difference. Second way is you square. You square the difference. So what is 10 minus 10 square plus 100? So there are two ways to see. You understood the problem of negative numbers, right? Negative and positive, they're canceling out each other. So that's not, that's not what we want. So we cannot perform this. So I need to make negative numbers positive. How do I make negative numbers positive? I need to make negative numbers positive by taking absolute value. Absolute value, again, if you remember mathematics, we write those parallel lines. Okay, absolute value will make this as minus 10 will be plus 10. So now everything is positive. So what we just did is we did average absolute value. Okay, in statistics, average is called as mean. Okay, so your mean difference is not useful. Your mean difference is not useful. Your mean absolute value is useful. So you call it as mean absolute value, mean absolute difference, mean absolute deviation. Okay, MAD. Okay, mean absolute difference. Okay, if you're using difference, let's use difference everywhere. So you're doing difference. See, this is what it means. You're doing difference, then you're taking average. You're doing difference, and then you're taking average. Here it means you're doing difference, then you're doing absolute, and then you're doing average. So this is your mean absolute difference. So mean absolute difference is going to be average of these values. Now you see 4.44 is MAD, mean absolute difference. And we can stop here. We don't have to go any further. But one problem with absolute value is higher and lower difference are considered as same. In situations where, okay, higher and lower difference are not given importance. Let's say customer care. So sometimes, okay, you might take more time to fix the bug, right? You might take more time to fix the bug, but that is okay, because it is within the SLA and it's okay. You don't want to extrapolate it. Okay, see, no, it takes more time. It took 10 days to fix it. You don't want to do that. So in that case, we use absolute. But some cases where you want to expand, you want to showcase that there is a problem. Like, so when talk about, let's say fraud detection kind of cases. Okay, in fraud detection kind of cases, you want to highlight those bigger problems, right? Because it's very risky thing. So you want to highlight, oh, you lost 10 lakh rupees. It should be highlighted more than losing 5 rupees. Correct? So there we use square method. Okay. So what you do is you do the square of the difference. So so I need to make positive, right? So square of the difference. So you do 100 and okay, so this is your square difference. So now what I'll do, I will find mean squared difference, MSD. So what is MSD? Mean. Okay, we did the difference, then we did the square. Now we are doing mean. Okay, you don't do mean, you do average, right? So this is your mean square difference. Now see 4 became 33. What is problem with this? Is there any problem with mean square difference? Yes, there is a problem. What is the problem? You started with days, right? 50 days, 70 days. And what do you end up with? Days square. Okay, they are not apple to apple comparison, right? It's not a good metric to compare. You started with days, you're getting square, days square. You started with apple, you're getting orange, right? Then we can't compare. So what we should do? You should do the square root of this. Because we did square, now we will do the square root of this. So what you do here, you do root mean squared difference. Okay, so first the difference. Okay, first difference, then you square the difference, then you take the average of the square, and then you do the root, square root. So in you can use SQRT here in Excel. It gives you 5.788. This is your root mean squared, right? So your MST is also called as variance. And your root mean squared error is also called as. So this is your standard deviation and this is your variance. Now is it clear? You'll forget. Variance is mean square difference. And you know why we calculate mean square difference? Because difference itself is not enough. We need to convert negative into positive. And also we want to retain that property. If the difference is large, it should come out even larger. So we're doing square. Okay. So square of the difference, then you do the average, that becomes your variance. But problem with the variance is that variance is square of what we started with. We have to bring it down to the same level. If it is days square, it becomes. So if you do the square root of days square, you get days, right? So then we do the square root. That's why variance is not used much. Standard deviation is used. Okay, so treat variance as a step, one of the steps of calculating standard deviation. So you will not find variance, usage of variance. We'll always talk about standard deviation. Okay, so standard deviation is the most used metric in dispersion or variability. And mean is the most used metric in the central tendency. So topic for today was central tendency and variability. So central tendency, you have mean, median, mode, and mean is the most used, median is the least used. In here, okay, you have in variability, we spoke about variance, standard deviation. Okay, so standard deviation is most used metric. Any questions so far? I'll pause for a minute. Okay, try to recollect what we have done. And let me know your thoughts.